Chang's canvas presents Euclid's Elements, the blueprint of geometry, one proposition at a time. Subscribe for the full series, Proposition 2 of Book 1. We have a point A and a separate segment BC. The goal is to build from point A a new segment with exactly the same length. We are going to demonstrate what Euclid did. His goal: construct at point A a new segment equal in length to BC. The given A is the required starting point. BC is the separate length to copy. His strategy: a locking compass would copy BC directly. Euclid instead derives that ability from Proposition 1 of Book 1 and two center-anchored circles. Keep these two givens fixed. A is where the copy must begin, and BC is the length we must reproduce. Join A to point B. Proposition 1 of Book 1 supplies the equilateral carrier. Sweep its two equal radius circles, whose completed intersection locates the helper vertex D. The two completed helper circles meet at point D. Now join D to point A, then D to point B, completing the equilateral helper triangle. Proposition 1 of Book 1 makes all three carrier sides equal: AB, DA, and DB. One tick marks that family, and DB receives only this single tick. Now extend DA straight through point A toward point E, and extend DB straight through point B toward point F. The circles will determine the exact cut points. We do not guess them. Center a circle at point B with radius BC and sweep it completely across the produced line. The completed circle cuts the produced line G. Now BC and BG are radii of the same circle, so they are equal. Next, use a whole distance DG as a radius and sweep the circle centered at point D completely. The completed circle cuts the other extension at point L. Now DG and DL are radii of the same circle, so they are equal. Here is the engine of the transfer. The first circle gives BC equal to BG, while the second gives DL equal to DG. Now subtract the matching equilateral sides. Remove DA from DL and DB from DG. Equal wholes minus equal parts leave equal remainders, so AL equals BG. But BG already equals BC. Since AL and BC equal the same segment, they equal one another. The required copy is complete. AL equals BC. Remember the final picture. The new segment AL starts at the given point A, and its length is exactly the given length BC. Why Euclid chose this route? A modern locking compass can carry BC directly to point A, but Euclid has not assumed that an opening survives when the compass is lifted and moved. Instead, he uses only center-pin circles and Proposition 1 of Book 1 to prove that the distance can be relocated. After Proposition 2 of Book 1, later constructions beginning with Proposition 3 of Book 1 may use this theorem as the rigorous substitute for carrying an unchanged compass opening. The elaborate carrier is therefore not wasted work. It makes lengths portable once for the rest of Book 1, so later propositions can reconstruct whole figures at remote places. In modern language, Euclid is building toward congruence by controlled rigid transformations rather than smuggling physical motion into the logic. This is part of our Euclid's Elements series, the blueprint of geometry, one proposition at a time. Subscribe for the full series.